Hi, welcome to another lecture in Calculus 3. We are going to continue our conversation about iterated integrals and area. So this is going to be the second set of problems we are going to look at in this section. I have chosen a few problems here for you. Let us look at them together and see how we approach these type of problems. So problem 1 is asking us to write the area between these curves as an iterated integral. So area between curves is something that you have studied in Calculus 1. Here we are using it as a way to get into more advanced topic of iterated integrals. So some curves are given and we have to have a general idea how they relate to each other. We don't need to be all that detailed about it, but we need to know, well, what's actually inside the curves and what's outside. And then we want to write the area using the concept of iterated integral. Second set of problems, the question is posed in the opposite direction, that some integral is given to us. The detail of the integrand is left out, but the limits of the integral are specified for us. And the question is, well, what was the area on top of which this integration was supposed to be done? So we are going into reverse and asking what was the region of the integration. And to make sure we understood it, we want to also change the order of integration. You remember we said we can go horizontal and then vertical, or we can go vertical and then horizontal. We want to switch back and forth between the two of them. The last problem is an interesting example that the problem, if we try to do it as it is going to be really hard, but if we switch the order of integration, becomes really easy. This is one of the interesting aspects of the problems in this section. Okay, let's go ahead and get started with the first one. So I have some curve here which is described as radical x plus radical y is equal to 2. Obviously our x and y have to be positive here for this thing to make sense. These two are just this is y-axis, that's the x-axis. So the area that's limited by all three, what is that? So let's go back to a quick sketch of this. So area bounded by radical x plus radical y is equal to 2, x is equal to 0 and y is equal to 0. So let's go do a quick sketch of this. Again, we don't need to be super precise in this section, so long as we know more or less how the various curves are situated with respect to each other. So x equal to 0, that's just y-axis. All of these things, points, x is equal to 0. Down here, of course, so y is equal to 0. Radical x plus radical y is equal to 2. Well, suppose my x is 0. Well, what is y going to be? Y will be, of course, 4 in that case. So suppose this is 1, 2, 3, and 4. So I have 1 point here, and of course if I go the other way, if y is 0, well, x is going to be equal to 4. So some point here. So somehow we are coming from this location to this location. You can go ahead and find a few other points in between and do a more precise of a graph, but it will be something like this. We are coming from one to the other in some fashion. So for example, of course, in between we have 1 and 1. If you want to have a couple of points, 1 and 1 adds up to 2. So that point, you see, it's sunken inside. Okay, so this is, let's do it in a different color so that, so this is radical x plus radical y is equal to 2. We want to figure out the area. The area means, of course, well, area bounded by these. So you hear that word quite often in this section, bounded by a bunch of things. So we have to define the boundaries and then we are in business. Okay, we said we have two ways of figuring out areas depending on which direction we choose to slice it up. If we can choose to slice it up in going vertical direction, or we can go horizontal direction. So if I want to go vertical, I'm going up first. So vertical means we are going dy. So dy is measuring going up. We said that to figure out the height of this, we need to have starting point. Well, I start at y equal to 0. I end up where? What is my ending location? Well, I need to know what is my starting location here. Suppose I'm at x. What would be the height of this? We have to take this equation and write it in terms of x. So I'll have radical y is equal to 2 minus radical x. And of course, out of that, I can figure out that y, depending on where I start, is 2 minus radical x squared. For example, if my x were 0, my height would have been 4. If my x is 4, like here, well, my y will be 0. So if I start at x, this location, the height is given by 2 minus radical x squared. So that's what I'm going to write here, 2 minus radical x squared. Okay, once I have dealt with this, that is, I have found out how tall it is, I multiply it by dx. So dx is going to be how wide this rectangle is going to be. So this, the width of it is dx. So dx times this height is going to be the area of one slice. Then I'm going to add all those slices to each other. Well, where is my starting point? My starting point is at x equal to 0 here. My ending point here is at x equal to 4, this location 4. And that is the end of this. Well, we had an option of doing this the other way. Let's just make a separate picture. So I'm going to be quick here. So it's something like this. And in the second choice, we are going to go horizontally. Calculate the area of each of those strips and then add them up. So in this case, I start at the y, and I need to know what would be stopping place for this strip. Well, for that I need to calculate the x of it. Just like what we did over there, it's going to be 2 minus radical y squared. Is that right? So in this type of integration, we are going to go horizontal first. So that's going to be dx. We are sweeping horizontally. We're starting at x equal to 0. That's starting point here. My ending point is 2 minus radical y squared. Of course, this whole integral is going to be just 2 minus radical y squared. Second round of integration, we are going to sweep from this bottom area all the way to this top area. So we are going to go from 0 to 4 again, and this time we are going to do integration with respect to dy. So that is going to be how we wrote this. Of course, now what is left is that you calculate either of these two. So the first one, how do you calculate it? Well, antiderivative of this is just antiderivative of 1 is y. You have to calculate it at these two locations and subtract it. So our problem becomes 0 to 4. This is just the height of that bar. So that's 2 minus radical x squared, then dx. Okay, so that's a very simple problem in Calculus 1, and I let you figure this out. So you can pause this perhaps and figure out that value. And this being an elementary problem, I feel comfortable that you surely will be able to do it. Okay, let's move on to the next. Our next question is coming from this question of sketch the region if the integral is given to you, and then exchange the order. let's go after B1. Problem B1. So we were given something like 0 to 4, 0 to y. Some function was detail not given to us, so we don't want to be distracted by that. It's irrelevant to the question. Dx dy. So this is given to us, and the question is, what was the region? Okay, can you tell what the region was from the detail? Well, what are the details? The details are just what you see in the limits of the integral. So let's go ahead and practice this concept here. So again, we draw the coordinate system. Okay, so in this problem, we are going horizontally first, going from 0 to y, meaning x ranges from 0 to y. So how do we do that? We choose some y location. So our x starts at 0 and goes as far as y itself. So stopping place for us is x equal to y. Starting location is here. So x equal to y, what does that look like? Of course, that's just the simplest thing. That is just a 45-degree line. Then y ranges from 0 to 4. So wherever 0 is, 1, say 2, 3, and 4. So the region of integration that was being targeted in this problem, that is the region. So we draw the two curves, and then we are all done. The problem also asks switch them around, meaning instead of slicing it in this style, go ahead and slice it in that style. So in that case, we want to start from this. This is the leftmost cut, the middle strip, and strips at the end of this thing. We want to collect it that way. Perhaps a very strange kind of analogy would be, if you have the region like this and you want to mow the lawn, you can mow all this horizontally, or can mow it vertically. You're doing the same thing. So here, let's do it. Let's reverse this thing. So we are gonna choose to go this way now. So if I want to go choose that way, we have a starting x location, and then we want to say our y starts here and y ends here. Well, what's my starting place? Well, still y equal to x, just that we are going to think about it in the opposite direction. So at x, our starting location starts at x and goes as far as, well, this is 4, f of x and y, and then we are going vertical first, then we sweep horizontally. So dx starts at 0, and this problem happens to end up at the same 4 location outside. So this is problem 4, what is it, 2b, I guess, or excuse me, B1. So that was problem B1. Now let's move on to the next problem, which is B2. So this was B1. Now B2. So B2 has the following look to it. It's from -2 to 2 of the integral from 0 to radical 4 minus x squared, some function f of x and y, and then dy dx. One way to remember this is the variable here and the variable there are different ones. So x and y, you see it there. So one way to catch our errors in this section would be something like that. So next, what does this thing look like? So again, let's go ahead and start with some copy of the coordinate system. So here's my x, y. So we are going vertical direction now. It's dy at a certain x. So if I start at a certain x, I'm supposed to go, y starts at 0 all the way up to wherever this thing is. So my stopping place is radical 4 minus x squared. So for example, if I am at 0, this becomes, suppose this is 1 and 2. If I go as far as 2, let's see, say this is 1 and say this is 2 almost. At 2, this becomes 0. So I'm going from here somehow to this location and then back down. Of course, I gave the problem away. I was going to ask you what shape is it. So the diagram tells us. So if you have y is equal to radical 4 minus x squared, if you square both sides, y squared becomes 4 minus x squared. So y squared plus x squared is equal to 4. So it's a circle of radius 2. It's a half circle. We are going from 0 to this positive quantity. And then we are going from minus 2 to 2. So I'm not cutting it short. I really go from minus 2 to 2. So the area that is being integrated here is this area. So what is the area? The area is a half circle. Now, next question. What if we were to flip this thing around? That is, I want to cut this thing horizontally. Horizontally meaning, what? Is that right? Well, you have to go all the way from left to right. It's what is the deal with this whole cut here? That's what I want to capture. Well, if x squared plus y squared is equal to 4, if I start at the y, what is my ending location? So my ending location is going to be given as x in terms of y. So what is that? Well, x squared is equal to 4 minus y squared. So x becomes plus or minus 4 minus y squared. Of course, on the right is positive, and on the left is the negative. So if I want to start integrating from here to here, I'll start from minus radical 4 minus y squared to plus radical 4 minus y squared. Whatever function I had, now I am sweeping horizontally, so that's the x. Then once I'm done with this strip, I have an idea what each strip is. I look at it that I'm starting at this low at 0 and gradually taking more and more of these things, going up and higher and higher, and adding them all like that. So I'm going from starting location is 0, ending location at 2, 0 to 2 of then dy. Okay, so first time around, what we were given, the strips were made like this. So you start from here, go to here's the middle, and then at the end you are down here, and then we flipped around and got it into this form. So that is the B2. So let's move on to let me see what was B3 that I've chosen for you. B3, so that's minus 1 to 1 and x squared to 1. Let's see if you can remember. Minus 1 to 1. So B3 was minus 1 to 1, and then x squared to 1 of some function whose detail is irrelevant. Then we have dy dx. So again, these two are the two different variables that we have in our problem. They're never the same. So again, what kind of picture are we dealing with? By now Hopefully you have the hang of it, and I want you to stop this, figure out the problem, and then come back and compare your answers against what we have. So our rationale for these pictures was for you to focus on that, cut off from everything else. Just look at that picture, think about the problem. So hopefully the picture reboots you, and then you have a better chance of doing this. Okay, so our verticals aim at some x location. And we ask, where does y go? Well, y goes from x squared to 1. Well, what is x squared? X squared is, well, let's choose some sort of unit of length so that we can draw something reasonable. Yeah, hopefully this is reasonable. 1, 2. So x squared, of course, our trusty parabola, which we have lived with it since maybe middle school. So that is my so at x, how high do I go, or where do I start? I start at x squared, so y equal to x squared is my starting point. Where do I stop? I stop at 1, so I'm already exceeded 1. This would be 1 in my picture, so that was 1 for me. So the region of integration is from x squared to this 1. Maybe I should have drawn it bigger. So the area we are integrating is this one. Is that right? So the area of integration, let's draw it in a separate color. So here I start at y is equal to x squared. I go as high as y equal to 1. That's how y changes. Now, how about flip? Well, in the second issue, we are going x, going from -1 to 1. So -1, starting x value to ending x value from -1 to 1. Now, I want to flip this, meaning I want to go sweep this thing in a horizontal direction first. So for y here, what is my ending place? So I aim at a particular location on the y-axis, and then I ask, where do I start, where do I end? Ending location, well, this is y equal to x squared. So you can say ending location is x is equal to radical y. Solving this thing, x equal to radical y, that is how far we go to the right. How about the left? Well, of course, we have a plus or minus here, so x is minus radical y on the left. So when I want to sweep this f of x and y, and I want to go horizontally, my x starts at minus radical y, goes to plus radical y. That takes care of this sweep. The next sweep, if I want to go in the vertical direction next, what is my starting y, my ending y? Again, pause that and try to answer it, and then come back and check. Well, my y ranges from this to that, so it's from 0 to 1. So the issue is that these two integrals are the same thing. It's exchange of, we refer to this as exchange of order of integrations. All of these problem, this is all exchange of order of integration. This is the category of the problems you want to, if you want to search for it, exchange of order of integration. That's what they're all about. Well, see what was the last of these things. So I have 1 through 10, 0 to logarithm of y, and then of course x first, y last. So let's write that.